and how they work and how they're connected to each other. Thank you so much for joining us.
Hi, everyone, and thank you so much for having me. Let's see, I'll just... Are you able to see my screen okay? Great.
Yes.
Well, yeah, thank you for having me. My name is Brandon Letzinger. I use he, him pronouns, and I'm speaking today from Seattle along the Salish Sea on unceded Duwamish territory. I'll be here to talk about bioregions, bioregionalism, and why developing regional strategies for fighting climate change is so important. If anyone has any questions afterwards, don't hesitate to reach out either via social media or email. Always happy to answer questions. If you've never heard of bioregionalism before, it's one of the oldest new ideas currently out there. It has been a part of Western science for about 50 years, but practiced by indigenous peoples around the world for thousands. At its most basic, it simply means living responsibly and using place-appropriate technologies within the confines of what our region can sustain. Optimally, it means that we are not only living sustainably, but are restoring and enriching the systems on which we all rely. This can be summed up as find your place on the planet, dig in, and take responsibility from there. Rather than citizens of the United States or Canada, bioregionalism promotes the idea that people are instead citizens of their watersheds. Regardless of political difference, by sharing a place, a region, a home, we share common values and concerns that arise from this, and must find specific strategies that will work best for all of us living here. For those not familiar, a bioregion is a region defined by the natural environment rather than man-made divisions. The external boundaries of a bioregion are hard and jagged, mountain ranges, fault lines, geology, hydrology, and from these hard edges, interconnected systems of rivers, weather patterns, ecosystems, soil types that all together define the shapes of our bioregion. This includes watersheds, ecosystems, and human communities. Such an area must be large enough to maintain the integrity of the region's biological communities, our habitats and ecosystems, and to support important ecological processes, such as nutrient and waste recycling, mitigation, and stream flow. And to include the human communities involved in the management, use, and understanding of these biological resources. It must be small enough, though, for local residents to consider it home. A bioregion is unique in that it's not just defined by natural borders, but also by the people living there. It must have a unique cultural affinity. It means that the livelihoods and interests of local communities should be the starting point and criteria for regional solutions and conversations. A world of bioregions. Whether they know it or not, every person lives in a bioregion. All around the world, these bioregions are the natural countries of the planet if human political borders were removed. We live in a world of bioregions. For myself, my own home is here in the Cascadia bioregion. The Cascadia bioregion is a way to define the Pacific Northwest through the watersheds of the Columbia, Snake, and Fraser rivers. It stretches for more than 2,500 miles from Mount St. Elias in Alaska all the way down to Cape Mendocino in Northern California, where the Juan de Fuca Plate meets the San Andreas Fault and the Cascadia subduction zone begins. In the east, it stretches as far as the Yellowstone caldera, defined through the Continental Divide and Rocky Mountains, and these borders are chosen because within them we share interconnected watersheds and ecosystems, and from which cultures based on place arise. Since time immemorial, this region has been an interdependent crossroads of trade, language, and dozens of nations stretching for as far as the salmon swim. Today, the Cascadia bioregion is home to roughly 16 million people, the 9th largest economy, and some of the largest old-growth temperate rainforests, including 7 of the 10 largest carbon-storing forests and tallest trees in the world. All of this is to say that our local actions here in Cascadia can have a huge impact globally, and that we have a lot of very special things to protect. So, why does any of this matter? In terms of fighting climate change and carbon sequestration, bioregions as interconnected ecosystems and communities with shared cultural affinities become leading frameworks to help us break down large, intangible goals to a local level with specific deliverable metrics. For example, even if some worry that our timber industry might be harming the planet, by supporting locally sourced timber from Washington, we have more control over how it is cut, the supply chain, and that workers are paid living wages, and can more easily change policies we think are bad than when random hardwoods are imported from Asia. Maybe someday, introducing industrial hemp as a faster growing alternative for paper projects could help reduce the carbon output even further. Other reasons that bioregions are very important is that current borders don't necessarily represent the physical realities of where we live or our communities, that nature acts bioregionally and does not stop at human-made borders, and lastly, that these borders halt effective community action and climate solutions. Right now, it is incredibly difficult to work across borders with different laws, different languages, histories, and contexts. For effective change, these answers must be bioregional. For example, this is the Sailor Sea bioregion. This is the ecoregion where I live, and it stretches from Vancouver, BC, all the way down to Olympia, Washington. It includes more than 9 million people, more than half of the entire population of the Pacific Northwest. You'll notice that running through the middle of it is an international border. This border cuts straight through the traditional territory of the Samiamu Nation, divides the hundreds of islands making up the San Juan Islands in Washington and the Gulf Islands in British Columbia, and was set where it is over dispute over an escaped pig between an American farmer on one end of Vancouver Island and a British farmer on the other. If you look closely, you can see Point Roberts, a community on a spit of land surrounded by Canada and completely cut off from the US mainland. Normally a geographic absurdity, but now with COVID and unable to get basic supplies, a public health crisis. Even though we are divided by an international border, we still share a watershed. Regardless of what country you are a part of, what we do in Seattle impacts Vancouver, and what Vancouver and Victoria do impacts us here just as much. This idea of bioregions is incredibly important because ultimately nature acts bioregionally, not according to arbitrary political boundaries. If there is a forest fire, it affects everyone living in our fire sheds, regardless of state. If there is a drought, it affects all of us in our food sheds, regardless of lines drawn on a map. If there is a flood, it affects all of us in our watersheds, regardless of political border. And if there is an earthquake, it affects all of us along the fault line, regardless of whether we live in an urban or rural area. Just like invisible borders can't stop wildfires, the impacts of climate change initiatives cannot stop at the border to be effective. Ultimately, no one city or state will ever be able to deal with these issues by themselves. One of the best examples of this is the Columbia River watershed, the largest in Cascadia and traveling nearly 1,200 miles through British Columbia, Idaho, Oregon, and Washington state. In all, it includes parts of 6 US states and 1 Canadian province. Its border is traced not by governments or treaties, but by every drop of liquid that finds a common path to the ocean. The importance of this river and how it is managed cannot be understated. Aside from being shared between dozens of First Nations, cities, and governments, the river is continuously at the heart of decades of legal disputes, often because of the way the river was divided into different jurisdictions and administrations and taken without permission by those already living there. In lieu of depleted salmon runs, water rights, fishing rights, ancestral rights, and the rights of travel across an international border, it also includes 15 million acres of farmland in both Oregon and Washington, the Hanford nuclear waste site, and dozens of dams that are responsible for more than 1/3 of all hydroelectric power in the United States. Looking at one city or state within a bioregion is like looking at a pixel on a screen, and we need to see the whole picture. By using the entire watershed rather than just one piece, we can assess need within a holistic framework and work directly with the stakeholders we need to sway those most impacted by our choices and work with everyone to build new strategies to address these problems. whether it is how we grow our food, produce our energy, protect the salmon, or fight climate change. These conversations and solutions must be bioregional. No one area, community, or state will ever be able to solve these problems by themselves.
We've got 1 minute left for you. Thanks, Brandon.
So, what does using a bioregional model look like? It means, at its most basic, work together regardless of boundary or belief. Think along watershed lines, not just city, county, state, or national. And make sure every community impacted is part of the decision-making process, and that justice, equity, and reconciliation is part of every solution. Use local resources when possible and place appropriate technologies that make sense within our bioregion, such as wind, solar, water, and foods, and products that grow naturally here that are adapted for our climate. And gather and use data based on regional models rather than state-specific models. So that's about it for me, and thank you so much for your time.
Great. Thank you so much for being here and sharing your thoughts, Brandon. And with that, we will take about 30 seconds. Got some good questions coming in for you from during the Q&A, and we'll actually hold off and answer those during the Q&A portion orally as well. And take about 30 seconds between presenters. Great. So our next presenters are Julianne Gale and Zephyr Ellis, and they will be presenting healthy soils, presenting on healthy soils, building healthy food, climate, and community. And they're co-presenting as two interested party presenters. So welcome to you both. Julianne and Zephyr are from the Mason County Climate Justice and giving a local perspective on this issue. Julianne is a community organizer and youth worker who's worked on climate in a variety of ways. And Zephyr is a documentary filmmaker, activist, and co-founder of the Mason County Climate Justice. With that, I'll turn it over to you both. Thanks for being here.
Greetings all my relations. My name is Zephyr Elise. I carry with me ancestral knowledges from places far to the south of these regions and lands we are gathered here upon today. But my people's knowledge of Turtle Island extends from the moments we first became the peoples of this beautiful continent. And it is in this good way that I have to pause and ask permission from the spirits and ancestors and the descendants of the peoples on these Squaxin Island lands for permission to speak and share what is in my heart in a good way as we all face the things we are facing together. I don't know any of you in this room, but I know we are all neighbors, and I am grateful for everyone who has put their mind to this.
Hello, everyone. My name is Julianne, and I just want to start by acknowledging that our world is changing. Whether or not we take any action on climate change, everything about how we live, what we eat, how we travel, where it's going to be possible to live as human beings, all of that is changing right now and more dramatically in the future, whether or not we choose to do anything about it. And so it seems to me that we might as well try to be proactive and take a stand to help shape the world we want to live in, a world that's good for all life. And I think that a big piece of what we need to pay attention to is that humans have very few basic needs. We need water, clean water, clean air, healthy food, shelter, and connection. And that's what we actually need to survive. And we get to shift to prioritizing those things. Many of us have experiences of sacrificing our comfort and giving something up because we have a bigger vision and we want something more, whether that's for our children or for our loved ones or for the world. And this is that moment that we have right now. And so I hope that you can take this opportunity as assembly members to think of yourselves as helping us make that shift and choosing to prioritize connection and joy and life and what we really need to live. And how do we do that in policy in ways that don't come at the expense of any other community or any other life. So I'm going to share my screen, and we're going to start with a little video. I'm sorry, let me share my screen with sound so you can hear the video.
Climate change is all about too much carbon in our atmosphere, right? But carbon's not our enemy. It's the building block of life. Everything alive is made of it. It's us. The problem and the solution are simply a matter of balance. It turns out we already have a technology that removes carbon from the atmosphere, and it's got 500 million years of research and development behind it. Plants, with sunlight and water, perform photosynthesis. They pull in carbon from the air and turn it into carbohydrates, sugars. Then they pump some of those sugars down through their roots to feed microorganisms who use that carbon to build soil. Voila, carbon moved. Plants pump it in and soil stores it. Nature's living technology is amazing. Unlike more carbon in the atmosphere, more carbon in the ground is good for us. It makes healthy soil, which is nutrient rich, full of life, and holds way more water. This means more nutritious food and crops that are more resilient in the face of drought. That's good news for farmers, families, and everyone that eats.
So, good news, there actually is a solution, and most of us have access to it, whether we're in rural areas growing the foods or we're in cities having small areas of land to tend to and grow healthy soil. The thing that we have to think about as humans is to support intact ecosystems, as all these amazing presenters have spoken about before us. We need to think that it's not just a force to cut down for resource, but it is a force that breathes for us, and it's a force that gives to a healthy underground of biological workers making life possible. And this healthy soil, the healthy soil carbon sponge, it's what makes this life actually possible on planet Earth. And it has so many different species and beings that are all important. And even if we don't see them, we have to support what is going on. An analogy to think about this, and if you have some bread and flour at home, you can do this yourself and kind of think about this idea. All those mycorrhizal, those fungi, all those underground biological workers are like the yeast in bread, and they're what really help hold that water when we get all that rain like we had a few weekends ago. Yeah, the top layers and some of the leaves and the upper things spread off, but that healthy soil sponge is really soaking in the water no matter how many times it's inundated. And it holds that and it keeps it from running off into the rivers. It's keeping the water available to the trees in the forest. It's doing so much work beyond just holding the ground and building things. Our suburban and urban soils, they're degraded, they're compacted, they don't have life. So water hits it and it just runs everywhere. It takes it and it goes, and this leads to all kinds of hazards, from flooding and landslides to wildfires and forest and other effects. And all this compaction and reduction of healthy soil, it is what is leading to desertification across the globe. And research, and people far smarter than I have done research to say that most of that has been how we've thought about growing our food and growing our cultures, our cities, and our empires. But the beautiful thing is soil actually knows how to regrow itself.
So what do we do to maintain or build a healthy soil carbon sponge? There's some basic principles. Number one, you want to keep the soil covered. And so here's a model of the same soil with different coverings. And what this picture shows is that the healthier coverage on the soil means less runoff into rivers. And it also means more water making it into the aquifers and into the ground, and cleaner water as well, making it into our underground water sources.
We have to keep living roots in this soil. It's not only what's growing on top, but so much more that's growing underneath the ground. And it is this entire biosphere. It's all these little microbes and fungi and things we probably don't even know about because they're smaller than I can see, creating cities and communities that help keep everything healthy and also help that carbon sequestration.
We also want to minimize disturbances for healthy soil. That means minimizing physical disturbances. So no tilling, no digging, clear cutting, mechanical mowing, because that breaks apart the soil carbon sponge in a way that it can't recover from easily. You want to minimize chemical disturbances. You can't create life by destroying it. So limiting pesticides, insecticides, and pollution sources. And you want to minimize biological disturbances, meaning you don't want any overgrazing or undergrazing.
Healthy soil and healthy life above and below ground means that there's lots of species and there's lots of folk and beings making this happen. And on one side, you can see when you're allowing a holistic management style, you're allowing the grazers and all the different plant species, you're getting cooler temperatures, you're holding more water on that land, and it is actually giving life. Whereas the compacted side on the other side, there's not a lot going on with life. It doesn't really support much.
And you can see the difference between holistic managed grazing on one side, the side with all the life, and where it's lacking. And number 5.
We have to pay attention to this whole picture. I know this seems really overwhelming trying to think about all these concepts interacting, but at this moment we get to observe where we are and try things and notice what happens if we're doing it with the desire to regenerate and to give as much life as possible. But we also get to respect all the thousands of years of knowledge that our host nations here in Washington hold and have these deep relationships and understandings already, and let them lead us in a good way to managing our resources.
So when we restore the soil carbon sponge, we get a lot of benefits, long and short-term climate benefits that also are good for communities and our health. For example, restoring the soil carbon sponge cools landscapes. Here you see an example of the same land and the difference in temperature between leaves and bare soil. It also reduces flood and drought. As you saw, holding more water means less runoff, so less flooding, and also less drought because the water is there when plants need it during times of less rain. Reduces sea level rise by holding more water on land. Reduces wildfire risks by providing more water for plants. Provides abundant clean water and more nutrient-rich food locally for all life. Brings degraded and desertified land back to life. Reduces forced migration because if you can grow food where you live, you don't have to move somewhere else. And humans and animals are much better at this type of agriculture than machines are. And so if we switch to human and animal-based agriculture and forest management, that means less carbon emitted, more connection to the land, and more meaningful work for more humans. So what does all this mean in terms of policy recommendations? We really trust your minds to take in all this information and get creative and think about what you think makes most sense for all of Washington State. But here's some nudges to get you started. Number 1, you can support farmers to transition to regenerative agriculture. Our example is New Mexico's Healthy Soil Act of 2019, but there were also some others in the chat earlier. You can subsidize living wage jobs to restore ecosystems and include paid training. I know lots of people who would love to do this for a living, but they can't afford either the training or there aren't the jobs to support them yet. We could have a moratorium on clear-cutting, monoculture, and pesticides. One example is bee sanctuary cities. You can incentivize local food growing, processing, and distributing. And this could happen in so many different ways. I'm just going to give you a few examples. You could legislate decreasing the hours in a standard work week so that people have more time to grow, harvest, and process their own food and medicine. What that means is, like, for example, you could start overtime at 20 hours a week instead of 40 hours a week. You could provide grants for microfarming and neighborhood processing cooperatives. You could create infrastructure for local composting and mulch. And, let me open that back up one more time. Sorry, thought there was one more. sometimes people ask, well, where are we going to get the money for all of these recommendations? And the thing is the government is already subsidizing mainstream agriculture. The government is already subsidizing multinational corporations. We have a regressive tax structure here in Washington. There's no reason we need to have the extreme wealth inequality that we have here. We get to move money towards the life that we want for everybody, which is a world where everybody has clean water, everybody has good food to eat, everybody is able to stay with their families and grow up where they stay where they grew up. And I just think that that we have an opportunity here in this transformation of society to end all oppressions and to bring everybody together and end up with something even better than what we have now, even as we let go of these material things that we've gotten used to. You want to add anything?
I come from nations and people who have lived through many changing times in this world and many changing times in what government structure, economic system was at play. But ultimately, we get to hold each other and grow strong communities, resilient communities, because all of us are here based on ancestral teachings and understandings and trines and experiments that have got us to this moment together. I thank you for your time and your attention.
Excellent. Thank you both so much for sharing your local perspective and joining us today. Appreciate it. And we'll be pausing between presenters before I present the next presentation for today.
Shall I share my screen?
That would be great.
Okay.
Excellent. Well, thank you so much. And now I have the pleasure of introducing Heather Trim, who will be presenting on zero waste and climate change as an expert presenter today. Heather is the executive director of Zero Waste Washington, and she's got more than 25 years of experience in environmental work, ranging from zero waste to toxic chemicals and habitat issues. At Zero Waste Washington, her focus has been on reducing upstream sources of waste and addressing downstream impacts, getting toxic chemicals out of products and eliminating plastic pollution, as well as building on the organization's signature producer responsibility of policy initiatives. The learning objective that she'll be touching on today and diving more deeply into is hearing about zero waste strategies and upcoming Washington state legislation. Thank you so much for being here, Heather.
Thank you so much. And hello, everyone. And Gretchen, if you can give me a 5-minute warning and a 1-minute warning, that would be awesome.
Great, I will do that.
Great.
Thanks.
So I'm Heather Trim. I'm executive director of Zero Waste Washington. We are a statewide nonprofit that is working to make trash obsolete. And we primarily do this by trying to help pass laws at the local and state level, research projects, and doing pilot projects in the community. We have 7 focus areas, which I'm not going to go into great depth here because I'm going to be talking about some of these later, but just wanted to show you the areas that we work in. And today I'm going to start with talking about our triple challenges, which are plastics, recycling, and food waste that are very connected to climate change, and then give you a flavor of legislative bills. Actually, I shouldn't say the word upcoming. It is now actually in place. Legislation has started. So let's start with the triple challenges. Zero waste is really interconnected with climate change. And this is a pie chart from EPA. Look at the red in the front of this pie chart. 37% of the greenhouse gas emissions are actually related to the provision of goods. That's products. It's the manufacture, transportation, and use of goods. This is a huge, huge piece of our climate change puzzle, and a lot of times doesn't get fully articulated when people are talking about climate change. This is a graph of the global use of plastic around the world done by sector. And it's from 1950 and to 2015. Before 1950, we really didn't have plastics. And after World War II is when we started to have them. And you can see that it has just been growing, growing, growing. And in particular, look at the blue at the bottom. That is packaging. The challenge we have is that between 30 and 40% of what plastic is being used for is single-use packaging like bottles, bags, the wrap around your toilet paper, the wrap around your candy wrappers. These are all things that we could reduce. And they're things that we use for just a minute or two, sometimes a little bit longer, but we basically fundamentally are then going to not continue to use them. So we're not talking about things durable like your glasses. And what is plastic made of? It is made of oil and gas. And part of what has happened here in the United States is we've had a boom in fracking in the last 2 decades. I'm actually a geologist. And when I was in grad school, what I learned about was these shale beds that we had in North America that were not economic to mine from until they developed new techniques, which are called fracking. And that is why we're actually now a major exporter of oil and gas in the world now. And what this has led to is a huge increase in new plastics resin refineries. This is one near Houston, but there are all these new proposals all around the US because the petrochemical industry is saying, well, if we're not gonna be able to use our material for fuel and energy, we're gonna use it for plastic. So there's like an explosion in this type of refinery being built all around the US and the world. And it is actually something that is a very big environmental justice issue. And also what has happened is we have all these different types of new materials that have come online. Every single thing on this slide is not recyclable. That can in the lower right-hand corner, that is actually not metal. That's a metal top with a plastic can melded together. They cannot be recycled. Everything else here is not recyclable because it's multi-materials put together. And then, of course, as you all know, when you approach a tri-bin like this, there's this thing called the 3-second shrug. If you can't figure out what goes in which bin, you give up and you just put it in the one closest to you. And that causes all sorts of contamination problems in our recycling stream. So that's about sort of recycling and plastics. What happened a couple of years ago is China said, no more, we're not going to take the waste of the world. And this was a very good thing for their own environment and their own circular economy, but it has caused a recycling crisis in the rest of the world, particularly here in the Pacific Northwest, because about 60% of our material was going to China. That's recyclable plastics, papers, scrap metal, etc. And so in the meantime, in regard to the recycling crisis, this is the cost per household in Washington for your recycling if you live in the unincorporated areas, the UTC, which is the Utilities Transportation Commission. It's gone up in the last 5 years dramatically, the cost, but unfortunately, the amount of recycling and the service you're getting has not gone up, and our rate of recycling has actually gone down in recent years in Washington. So why is recycling a good thing from a climate change perspective? It is way, way better from an energy savings if you can recycle things than make them from scratch and from pulling from the extraction. So the best example, of course, are cans. If you see the top there, 95%. But even glass is extremely good to recycle rather than to take from virgin materials. And you can see plastic is actually quite high up there as well. Now let's move to food and organic material. This is an excellent report, which actually your host, Cascadia, wrote. It's an awesome report, get credit to them. They do it every 5 years. Ecology does this, and they look at what is the material going to our landfills in Washington. So this is a graph showing all of the materials going to the landfills, not going to recycling or compost. And you can see that the largest component is organic material, 28.5%. This is a big problem, big challenge. This is that same information looked at a little bit differently. This is saying what are the most 15 most prevalent material types. And you can see that I put a box around food, and they very carefully have delineated edible food and inedible food. And the punchline here is this: 17% by weight of what is going to our landfills is food waste, and about half of that is edible food. We should be eating this. We have hungry people in Washington, and the other half is inedible food. That should be going to animals. It should be going to compost. And that really ties into the previous talk that you heard about, regenerative agriculture. And why do we not want to send organic material to the landfill? And I imagine you've already heard about this, but the problem is that that landfills are a major generator of methane. Methane is 20 times more potent than CO2 as a greenhouse gas. This is a huge, huge problem. And landfills in the US are 1/3 of our methane man-made source. So now I'm going to shift to talking about legislative bills. Right now in the legislative session, there are quite a few zero waste bills that are moving forward. I'm going to only talk about the top 3 that I've bolded here because these have a very strong climate change connection, but also fluorinated gas in HVAC systems, which I'm not going to talk about, but you can ask me questions about if you'd like. So to address the plastics and recycling crisis, we feel that we need to reduce the use of unnecessary plastics in the first place, and then also build markets and restore the recycling system here in Washington instead of taking it across the ocean to other countries. So Senator Doss and Rep. Liz Berry have a bill that is underway to address recycling and plastics. It includes 3 pieces. One is to require that plastic beverage bottles have recycled content in them. So instead of taking the virgin oil and gas, you would use these percentages of recycled bottles so that this would actually be incredibly powerful for helping drive the value in our recycling system as well as address climate change. Many companies have already made pledges that they are going to get to 100% recycled content. Naked in the bottom right-hand corner, they already are using 100% recycled content in their bottles. The second component is to ban styrofoam. This is a problematic item in the recycling system, major sort of contamination problem. And styrene in hot coffee, in styrofoam. If you drink hot coffee or you're eating hot soup or hot things out of styrofoam, there is a chemical called styrene in the styrofoam that migrates into the food, especially when the food is hot. And this is a probable carcinogen as of 2 years ago, they noted that. It also bans recreational coolers and packing peanuts. The next and the last piece of this bill is to ask first. So when you go to a restaurant or a takeout, you wouldn't just get a fork or a condiment pack. You would they would say, do you want a lid, a cup, or condiment or straws? So this is an ask first, and this will be a big. Are we at 5 minutes?
5 minutes, yes.
Okay, perfect. I'm actually doing ahead of schedule. This is great. Okay, so the next bill, which is my favorite bill, actually, is being championed by Mia Gregerson, who is the rep from the Tukwila Federal Way area, I believe. It's got a terrible name, so ignore the name. What it is it's right to repair. And repair is a major way to actually reduce greenhouse gases. And I'll explain that in a minute. The point of this bill is to say that the major corporations have to allow the local repair shops and the independent repairers and the public access to the parts, the tools, and the diagrams of the inside of electronic devices, everything from laptops to cell phones to Game Boys and etc. And when those devices are 5 years old, at cost, so they wouldn't be giving them necessarily for free, but right now they don't let the independent repair shops have them. So if you have, for example, an iPhone and you go in and try to get a new battery, you can't get an Apple battery from an independent shop. So this is a really big deal for small businesses and creating more jobs. So if you repair an item, you get 13 more jobs than if you recycle them. And equity, we have a major problem with COVID of lack of laptops. If we could refurbish laptops and other devices for students across the state, this is huge. And then look at this climate change impact. This is just one example. If Washingtonians use their cell phones 1 year longer, each of us, it would on average reduce greenhouse gases the equivalent of 14,600 cars in a year. This is a huge impact. If we keep our items longer before we throw them away, we have major greenhouse gas, and if we repair them. Last bill I want to talk about is Senator Doss again has a bill, and this ties in directly to the talk you just heard, to get the organic material out of the landfill and to start to use it for compost, to feed people, and to feed animals and make energy, biogas. So we have a hierarchy that we use, and that's the triangle on the right here. Our first goal is prevention. Don't use it in the first place. Then reuse and repair, recycling, and then finally recovery and disposal. And as you can see, the arrow that I added for you all, the blue arrow on the left, the more you do everything at the top, the better it is for greenhouse gases. So the takeaways I have for solutions, and you might have some other really great ideas of how to address some of these things, are: one, consume less. The less you consume in the first place, the better it is for greenhouse gases. Repair and reuse things, recycle, huge value of that, and then compost or feed people or feed animals, not landfill the organic material. And that is the end of my talk. Thank you. Maybe I'm ahead of schedule.
Excellent. You are, which is amazing. Great. Thank you so much, Heather. And we've got a lot of great questions in the chat, which we'll be bringing forward during the Q&A. So thanks everybody for continuing to provide great questions throughout the course of our day today. And with that, I'm going to take a pause before we move into our final presentation for the day, which then leads to our Q&A.
Hello there.
Hi there, Jason. Excellent. So I'm going to go ahead and introduce you, Jason, before I turn it over to you. And thank you so much again, Heather, for joining us and for your presentation on zero waste strategies. And now moving into, as I mentioned, our final presentation for the day. So Jason Steinberg is joining us, and he'll be presenting on green roofs as an interested party presenter. And Jason has worked in scientific research, including at the University of Chicago's Environmental Neuroscience Lab, examining the influences of natural and urban environments on psychology, behavior, and health. Jason is currently finishing up a Master of Urban Planning degree at the University of Washington in Seattle, focusing on environmental planning and urban design with a thesis on carbon sequestration and green roofs. So Jason will be focusing on how green roofs can support climate mitigation. Thanks so much for joining us, Jason. And with that, I will turn it over to you.
Okay, thank you. I'll share my screen. Okay, hi everybody, hope you're doing well. All right. So my topic is green roofs and equitable climate mitigation. So this is what Seattle looked like before it was a city. It was lush forest. And this is it today. It's still the Emerald City after all, but it's changed a lot. But it's not just Seattle that's changed. Statewide, cities have been growing, towns have been growing. Between 2010 and 2019, Washington's population grew by 13.2%, almost 900,000 people. Meanwhile, 203 out of 218 cities grew and 58 out of 69 towns grew. So what does that mean for buildings? This is Yakima right here. It's about 93,000 people who live there. That's just an image of all the buildings. And that's Yakima on the scale of all of Washington state. So there are lots of buildings. Sorry, it's not moving forward. There we go. And so thinking about how cities are going to continue developing and growing population and in terms of their built features, how can we utilize the built environment to help mitigate climate change? And so just a reminder that CO2 gets absorbed into plants. As they grow, the plants store that carbon within them. And sometimes it goes down to the soil as well. So when we look at Bellevue or Spokane or other cities, how can we vegetate these cities in a way that is beneficial for people and also mitigates carbon emissions? So green roofs. And there are many different forms and varieties. The main ones we'll be showing here are extensive, semi-intensive, and intensive. That just means more soil, different types of vegetation. And this is the extensive green roof. This is the most common type because it's cheap and lightweight. Semi-intensive is more like a meadow and small shrubs. And intensive has trees, large bushes, and large amenity spaces. And there are a variety of types of plants that you can grow on green roofs as well. So briefly, there are a number of layers in green roofs. There's the vegetation and soil, and then the layers that protect and help the vegetation and soil, as well as the roof below. So when we think about roof space, how much is there in Washington? So it's hard to have an accurate answer, but from an analysis I did, there are about 26.7% of Seattle's land area is roof space, according to data in 2015. Spokane currently about 12.55% of the land area in the city is devoted to roofs. Now there's a wide variety of cities and forms, so let's just assume that 10% of city lands are roof space. That's about 167 square miles of roof space statewide, which is pretty much exactly 2 Seattles. So just imagine 2 full Seattles are just roofs. So let's think, if we can vegetate them, what would that mean for absorbing carbon dioxide from the atmosphere? So based on a number of studies, and an average of 4.5 kilograms of carbon dioxide per square meter per year means about 1.45 million metric tons of carbon dioxide absorbed per year. That's the same as all of Seattle's residential, commercial, building, energy, and medium heavy trucks. The emissions from those, and about 1.46% of Washington state emissions in 1 year. The highest number found in a study was for herbaceous perennials and grasses, kind of like a meadow. And if that was instituted statewide on 75% of green roof areas, it would be over 25 and almost 25.5 million metric tons per year. That's more than all of Washington state's residential, commercial, and energy heating emissions for 1 year, about 56% of Washington transportation emissions, about 25.6% of the state emissions in 1 year. Now we have to consider that for smaller plants, they reach a point where they don't grow anymore, but it's still going to be storing that carbon overall. But when you think about woody plants like bushes and trees, those keep growing and keep storing carbon and store more than the small plants. But that's not the only benefit of green roofs. In terms of carbon emissions, there's also reduced energy usage compared to most other types of roofs for heating and cooling. There's some debate about white roofs, and we can talk about that later. There's the reduced urban heat island effect, because vegetation has a cooling effect, and that also can reduce energy use. Urban agriculture, in a way that could complement Washington's agricultural economy, could reduce transportation emissions for shipping food. A roof membrane for green roofs lasts twice as long as regular roofs, so that saves on carbon emissions for the replacement as well as cost. Stormwater runoff, saving water from being run off into the streets and sewers and air bodies, air pollution removal, sound insulation, increased biodiversity, social opportunities like communal gardens, psychological benefits, increased natural aesthetic, and more. Potential concerns that people have are about cost, structure, and maintenance. The cost is higher upfront compared to traditional roofs, but the evidence is becoming clearer and clearer that there are long-term savings from these per building, and also collective benefits, as well as job creation. And that relates to maintenance, for example. And the maintenance depends on the type. There's more in the first few years getting them settled. Structure is also consideration. There have been studies about this. There was some engineers that found in Portland that extensive roofs, green roofs, did not need more structural support. But it depends on the type, and it's a good idea to have engineers and others consider that for safety. There are a lot of policies. I spoke with people who've been involved with a lot of the policies across the nation and North America involving green roofs. Some of them are options, some of them are mandates requiring green roofs on new construction, and there's some details to that we can get into. Recently, San Francisco in 2017, Portland in 2018, New York City in 2019, and then New York State also had a tax credit or a reduction in costs in 2019. So based on that, looking at the Washington state policies, there were some that give it as an option within a larger requirement for green space. Some give benefits like density bonuses. And then in terms of green roofs existing, most are in Seattle, a few in Bellevue, Tacoma, Kirkland, Bellingham, Spokane. Equity considerations for this, less vegetated parts of the city should be able to get more funding for more intensive and biodiverse green roofs in order to help increase the amount of vegetation available and those benefits that are less available currently. This should be paired with other policies. So green roofs increase property value, and we want to make sure that doesn't lead to displacement. So we would want to increase housing supply and provide affordable housing for this case and in a larger sense. And also we want to avoid greenwashing. So green roofs have tangible benefits, but it doesn't mean that we should avoid the sources of emissions and more fundamental issues in green space, climate mitigation, and equity. So policy recommendations, I recommend a green roof mandate or requirement on all new construction and major renovations in all of Washington's municipalities. Roof space should be covered except for solar panels, heating, air conditioning, ventilation, access, amenity spaces. And the non-green portion should be white to reflect heat. Where possible,
And
building bonuses should be used to
Jason, sorry to cut you off. We've got 1 minute.
Okay, incentivize more intensive green roofs, equitable financial assistance. Integrating this within city code could lead to faster permitting processes, gather professionals to consider the climate specific aspects in different regions of Washington, have a maintenance plan, especially in the first few years, update policy as scientific insights continue, woodier plants are better, etc. Solar and green roof combination, they have mutual benefits. Green roofs cool down the solar panels, make them more efficient. Solar panels provide shade, so it can lead to more biodiverse green roofs. Also, looking larger, look at green walls and solar walls. This is an example in Seattle right now. And then some other examples of green walls that have similar benefits. So thank you to several people I've talked to. References, I know I spoke fast. I'm happy to go into any more detail. I'm also gathering more references to share with you. But thank you so much.
Excellent. Thanks, Jason, so much for joining us and sharing your local perspective. And with that, we are going to move right into our Q&A period. Again, feel free to grab a glass of water, grab a cup of coffee. And we've got a half hour left with you all, and that involves our Q&A portion and then also the around the campfire reflection, general check-ins with your fellow assembly members. And so first question for Q&A is for Brandon, and this is from Puneet from Sammamish. Are bioregions recognized by countries/local governments?
Yeah, it's a great question. The short answer is that bioregions and ecoregions are recognized by a wide variety of governments around the world, but that there's no standard definition or ways that they're implemented. So Canada uses maritime bioregions. The United States federal government uses different levels of ecoregions, and probably Australia is the closest to incorporating bioregions in parts of their planning and in public health, as well as their environmental policies. But I think that Cascadia probably has one of the most well-defined bioregions, that currently exists.
Great, thank you, Brandon. The next question is from Bethany from Warden, and this is a question to you, Heather Trim. How much carbon is produced in the recycling process?
I saw that question. I don't know the answer. What I have are the relative benefits, and I could definitely look that up and figure it out for you. Because what we're looking at is if you recycle or if you don't recycle, what is the major benefit of that? But yeah, there's no question. If you recycle, you are using greenhouse gases because you have to have the transportation to the facility, you have to process it, and then you have to make new things. So it's just the relative major benefit of doing it, but there is that's still consumption. You're still consuming.
Great, thank you. And the next question also is to you, Heather, from Angela in Vancouver. Is there a state budget designated for some of your suggestions?
Sort of. So we do have a litter tax that is paid by groceries. It comes out to about 20 million every 2 years, and that is used to help with recycling and litter pickup and things like that. But what we're actually looking at, and this is something you all could really noodle on and figure out how this could work, is if we do carbon pricing and we're trying to get stuff out of the landfill, does that provide funding for expanding infrastructure, compost infrastructure, doing a way better job on recycling, et cetera, things like that. But there's not, other than that litter tax and some money from some oil hazard tax, there's really not a dedicated funding.
Great, thank you. And the next question is for you, Jason, from Sue from Medical Lake, and also Robert from Bellingham, a combined question to you. Flat roofs are a challenge in our area due to heavy snow. Is the green roof feasible cost-wise for steep roofs?
That is a great question, thank you. I do think it depends on the circumstance. Green roofs on steep roofs are definitely doable. There's even a rule in Copenhagen to require green roofs on new buildings that have a slope less than, I believe, 30%. And so it does happen. in terms of, yeah, so snow, there's some interesting energy benefits compared to other roofs regarding that. But in terms of the weight, when they design green roofs, they have to take into account the saturated or total possible weight. So if the soil becomes saturated with water, they need to consider that weight. So I would imagine that where there is heavy snowfall, the engineers need to consider that when they're designing it. What that means for the cost, I don't know the exact answer. It depends on the amount of snowfall. That's a good question. Yeah, but there are places where there's snow: Toronto, Chicago, other New York City now with green roofs, and they get a decent amount of snow. So
Great, thank you. The next question is for Brandon from Chris from Linwood. Have any of the communities across the area, oops, the question went away for just a second. Mike, yeah, thank you. Have any of the communities across the area, regardless of boundaries, started their own local conversations that you are aware of?
Yeah, I think so. Bioregionalism is really interesting in that it's not just around physical sciences. It's very much a cultural implementation and creating a sustainable culture for everybody living here and really looking for those place-based solutions. So almost every different initiative, around bioregional principles and thinking really starts with grassroots conversations, and it starts from these coalitions just like this, of people coming together, talking, and then also though talking deliberatively. And so that means coming together to really take action around an issue, not just around education and support. And so this is a perfect example of kind of a bioregional discussion. Another really good example would even be kind of how the naming of the Salish Sea happened. A lot of these discussions, I think the idea was first floated in 1988, and then there's been a lot of different meetings and planning and kind of coordination between different coalitions, especially in the 90s and early 2000s, until it was kind of finally recognized as a place in 2012. So these local conversations, I think, are where all change really stems from and starts. And then by getting together and coordinating, that's where the action kind of comes in and developing these effective strategies.
Great, thank you so much. The next question is from Zach in Bothell, from Bothell. And this is a question for you, Heather. What % of recycled material ends up in the landfill instead of being actually recycled? And let me clarify, what percentage of the material we place in recycle bins ends up in a landfill instead of being recycled?
Okay, so that is an awesome question. Because we're in a recycling crisis right now, it's called a residual. So you put stuff in your blue bin and you think it's going off to the recycle system and being recycled, but there's the residuals that don't actually end up being able to be recycled. And I was just on a webinar last week, and they said in California the level is as high as 30% right now. Now I don't think it's that bad here. We have some better systems in place, but there is no market for some of the materials. So you have glass. We have a glass place here in Washington that can recycle the glass. The metal's getting recycled really well, but the plastics, if it's a number 1 and number 2, those are getting recycled. There's good markets for those, but the 3 to 7s are very difficult. And there are items that you're putting in your bin that are not recyclable, and those become part of the residuals. So this is a big issue, and we have another bill that I didn't even discuss for next year, that if you want to invite me to one of your groups, I could talk to you about it. But that would make it so that everything that is given to residents in Washington is recyclable, compostable, or reusable, and otherwise you can't use that packaging.
Great, thank you so much, Heather. The next is a combined question from Jason from Seattle and Sue from Medical Lake about green roofs. This is for you, Jason. What are the disadvantages of green roofs, and are bugs an issue?
Disadvantages is one that often makes a lot of people hesitant, is that upfront cost, and can they afford to put it in? And this relates to a number of topics. I think one is we need, for this, and a lot of climate action is about long-term thinking. And so there are long-term cost savings, whether it's reduced energy, whether it is health benefits, whether it is several different things. There are long-term cost savings, and the studies are showing that. When it comes to people who can't afford it in the first place, there needs to, I think, be some type of way to help financially with that. yeah, there are a number of ways that could be discussed, but I think that is an important aspect. In terms of bugs, that's a good question. In Western Washington, I grew up in the Midwest, and compared to that, Western Washington doesn't have many bugs, so I haven't seen too many up on green roofs. But I don't know the exact situation in other parts of Washington. But in terms of bugs actually in the ground, there are some maybe small ones to help with, soil decomposition and things like that. But it's not an issue because there are protective layers that would prevent it from getting into the building, so that wouldn't be an issue. Yeah, and I can expand more on those questions if you want. I know there are other questions.
Great. Thank you so much, Jason. The next question is for Julian and Zephyr from Barry in Bellevue. Let's see. What is the difference in yield between no-till and conventional plowing and planting farming?
So in the long run, yield is increased dramatically by healthy soil. Sometimes in very degraded soils or soils that have been really tilled for a long time, or a lot of pesticides have been applied, so there isn't as much life in the soil. There's a transition period of a few years, and that's a lot where government subsidies can help. But after you make it through that hard part, you have much greater yields at that point. And it's quite hopeful because unlike conventional agriculture, over time with conventional agriculture, you need to apply more and more pesticides. You need to apply more and more fertilizer because you're killing more and more of the microbes and the mycorrhizal fungi and the earthworms and all of that in the soil. So when you transition, it's the same with almost everything about climate change. You can have a short-term gain now, but you're selling the future of your children and your children's children and your children's children's children for that very, very short-term gain. And I think we got to shift our priorities. Do you want anything?
And not only does yield get better and stronger yields for the farmer, but you're getting more micronutrients, nutrient-dense food. So it's a win for the community. It's a win for whoever's going to be there. And, hopefully you're putting some of that back to compost, and your compost is going to be healthier, and adding compost back into the thing sequesters more carbon, brings more yield, brings more nutrients. So it's this beautiful cycle that when it amplifies is actually a good thing for everyone involved.
And also, reducing pesticides and fertilizers and things that poison humans, because that's the point of an insecticide or pesticide, is poison. You have healthier workers, and that's also good for the community.
Great, thank you so much. The next question is for Heather from Travis from Snohomish. What caused the major drop in plastics between 2005 and 2015?
The drop in global use, or the drop,
Yep.
I'm not sure what I was saying.
I believe
Okay.
you had a graph.
Mm-hmm.
Yeah.
Okay, so I had a graph. Yes, that's okay. I was going to point that out, so I'm glad you mentioned this. So on that graph that I showed, which was from the use over the entire world from 2050 to 1950 to 2015, there's a recession that was in 2007 that actually shows up on that graph. And so I know that once they extend this graph out past 2020, 21 and 20, we're going to see another huge dip. And because it's amazing how embedded plastic is in all of our lives. So that recession shows up on that graph as that huge drop.
Great, Heather. And there's another question for you from Gabe from Vancouver. How do you help the companies that do recycle to make it a business forward decision to maintain it at a high level? And if recycling is not a viable business, it goes away. It's already nearing that level, and that concern.
Awesome question. So that's this bill that I was mentioning. It's HB 1118, which we started this year, and we're going to move forward next year way more aggressively. So that has the standards that everything has to be recyclable, compostable, or reusable, but it also has a major thing, which is producer responsibility. The producers pay for the end of life of recycling. Recycling would become free for everyone in Washington. It would be paid for by the manufacturers. And this is what we have in Europe. It's been in Europe since 1994, in Germany, and all in Europe for decades, and in Canada. And I didn't talk about it a lot in this because I had only 15 minutes, but it's a fabulous thing that if we could get this here in Washington, it would make a huge difference. It would basically completely revamp the recycling system, so it would become viable for people to do recycling in terms of the businesses. It would create all sorts of jobs. It would be great for greenhouse gases, and it would make it free for you all to recycle, and it would also incentivize less waste in the first place.
Excellent. Thanks so much, Heather. The next question is for Julian and Zephyr from Sue from Medical Lake. Are there any regulations for farmers to let their ground rest, go fallow for a year or so? Is that voluntary?
As far as I know, there are no regulations in place, and I do think this is one place to think about whether it's regulation or support and subsidy to allow farmers space and support to do and make healthy decisions for their lands and their yields.
Great. Thank you. The next question is for Jason from Michelle from Friday Harbor. How do green roofs keep mold from entering attic space? And this will conclude our Q&A for today.
Yeah, thank you. Well, I haven't read of reports of mold getting into buildings. The understanding I have is there are numerous protective levels preventing from happening. I had to skim through the layers image on my presentation, but there are protective layers. There's a waterproofing membrane that makes sure water does not go through. That's the main reason that there isn't mold. It's a protective layer. There's also, like for example, a root protection barrier that prevents the plant roots from digging into the roof, and that would also help with preventing the water. The thing with water, the benefit of green roofs is that they absorb a lot of the water that would normally go on the roofs, and then they use it for the plants, and then it gets evaporated up. When it's very wet conditions, I haven't seen anything that says there's mold. I believe it's because of those protective qualities. It doesn't get inside the roof. But it is important to remember that the benefits for carbon, for financial, etc., in the long term are better when the green roofs are installed properly, when they're installed well. Because if you don't install it well and there is some type of leak in the membrane, then that's not good. So it's required to produce them well. But if they're produced well, then it shouldn't be an issue.
Excellent. Thank you. And thank you to all the presenters that came both in the morning and now the afternoon, and for sharing your responses to the great questions we've received from the Assembly members. I want to remind all the Assembly members, we have each and every one of your questions. We know that we didn't get to all of them, both in the morning session as well as now. We mail these questions out to the presenters, are getting responses to them, and we'll be putting them in that folder that we'll be sending you all a link to within the next couple of days. So all your questions will get answered as we get responses from presenters. And thank you all so much for your thoughtful questions. And with that, I am going to turn it over to Mike.
Great, thanks, Gretchen. So we're going to put up a slide here, just recapping again what we heard today and bringing it back to some of our learning objectives today. Recognizing we heard from a variety of many great speakers and presenters spanning interested parties and experts. And we also recognize it's a lot of information to take in. So just zooming back out to the 10,000 foot level. So again, reminder, we had multiple experts and interested parties presenting about the environmental considerations of climate impacts and climate mitigation solutions. We heard from Dr. Mead Crosby, Paul Williams, Brandon Letzinger, and Dr. Jessica Holofsky about the climate impacts to a variety of ecosystem types and habitats, both in Washington State, but also considering how Washington State is interconnected with our neighbors as well. We also heard from Dr. Holofsky, Jessica Randall, Julianne and Zephyr, and Brandon about the potential of natural ecosystems and habitats and how they can be a critical component for climate mitigation solutions in this state. And finally, we heard from Heather Trim and Jason Steinberg about connecting environmental solutions across other sectors, specifically roofing and waste, and thinking about how can we be environmentally forward and sustainable in these sectors, and how solutions, especially upcoming state legislation, can continue addressing the sources of greenhouse gas emissions. So I hope, again, we just wanted to bring it back out to the 10,000 foot level to just remind you about how all of these presentations are interconnected and continues building on the past 2 learning sessions as well. So now we're going to go back into our pre-assigned groups. Again, reminder that we'll be meeting with these same groups throughout the assembly, and this is just a time for you to share and connect about what you heard from the other presenters, how you're feeling, if there's other resources you've come across or read, additional questions. And we'll reconvene for the last few minutes to share out some next steps. So I'm going to check in with Gretchen and Emily to see if we have the breakout groups ready.
Yeah, thanks, Mike. Yeah, we're all set. So I will start, we'll open them now.